I recognize from previous RethinkDB meetups, and for you this may be familiar territory, but I want to talk about not just RethinkDB, but actually what it takes to actually build a real-time app and deploy a real-time architecture. So first question is, what is RethinkDB? So RethinkDB is an open source database that is specifically built to help make real-time apps really easy to build and scale. It's about 5 years old. We've been working on it for about 5 years. There's a team of about 100 contributors around the world who build and contribute to the project. And it's actually the second most starred database, open source database for NoSQL on GitHub. So it's got a lot of people using and playing with it. There's a lot of companies that have built all sorts of real-time apps on it. If you're curious about what companies are using it and how it's being used, come talk to me later. I'm going to talk about some use cases in a bit. But the first thing I want to talk about before anything else is what actually is a real-time app. So I think everyone remembers the first experience when they started using Google Docs. Someone said, try Google Docs, it's really cool. And you open it up, you see this like white page with a blinking cursor, and you start typing like, oh, it's a text editor. And then someone else joins, and then you start to see their words appear and their cursor, like, oh my god, wait a minute, this isn't just a text editor, this is really cool. And that's a very visceral experience. And since then, people have really sought to build those kinds of apps because they really give that kind of visceral experience. You could just see people typing in real time and communicating, and it's a very pleasant visceral experience. So this is what people want to build, these kinds of experiences. Another app that I know and love that we use at RethinkDB a lot is Slack. I think, raise your hands if you use Slack, by the way. Yeah, there we go. So almost all the room raises its hands. Every time I mention Slack, everyone says, we love Slack, we know Slack, it's amazing. It's funny because everyone's tried to build chat before, except like they did it right, like they made all the right decisions. I get an email each week which says a report on how our team is using Slack, and I consistently get, me or Christina, consistently get most emoji for that week in Slack. So the thing is, Slack, what makes it really special, it's not just that it's chat, it's that you have your mobile client, and you have your desktop client, you have your web client. And no matter where you're typing, things are just still popping in and appearing in real time. And it feels like it doesn't matter where you are, you're still connected to your team. That kind of experience is why Slack is as popular as it is. But the thing is, building this is really, really hard because Slack has to figure out all these different people connecting it for different clients and how to manage state, how to make sure that you have the same messages appearing and popping in the right order, in the right fashion. And that's because building real-time apps is really, really hard. It's easy to build something simple, like a small little like test app on your laptop, just sort of playing around, using tools like Angular and Socket.io. But the problem is that once you actually want to build an architecture, once you actually want to ship a product, things get really hard. For one thing, and this is the biggest problem, it's really hard to keep track of state in a real-time app. I'm going to show you an architecture diagram, which I apologize for, because I know that they're always really dense and complicated, but it's really useful to be able to understand what's going on and why it's hard. If you look at this diagram that I have up here, you can see that we have a couple real-time web app servers. In this case, take Slack. You have a couple of servers that are running like the web clients for Slack. They're working with all the web clients for all the Slack users, but then you have like your mobile users who have different needs. You can imagine, for example, geolocation is something that matters on the phone but doesn't matter on the desktop. So they have like different needs. And the problem is that these Slack messages are getting pushed somewhere to persist. Let's say like your database. But because it's really slow to access a database, to find out what's new in the database, because it's a slow part of the architecture, people started using things like queues, tools like RabbitMQ, to be able to communicate state between all these different servers. And the problem is now you've split your state between what's living on the app server, what's living in the database, and what's living in the queue. And because of this, it's hard to figure out what's actually the current version of reality. And so as you add a component to each part of the stack, these things get exponentially harder to add. And the reason for this, as I mentioned, is that in order to be able to work with the database is you got to pull the database. Because databases have no way to do anything but you got to ask it a question, and then to find out what's new, you got to ask it again very quickly. And that action of pulling the database means that you have to continue to keep track of updates. You got to hammer it with questions. And that's really cumbersome. That's not a pleasant experience from the developer side, nor when you want to build these architectures and you have hundreds of these app servers hammering the database with the same query over and over. Because it's so hard, it makes it really, really hard to add new functionality. So every time your team wants to think, OK, we want to add a new real-time feature, now you've got to think, how much more complex is my architecture going to get? And that's a paralyzing effect when an engineering team just wants to build new features really quickly. And on top of that, this is a little more subtle, but if you've built these kinds of things, you'll understand what I'm talking about. If you have messages, let's say a Slack message, that needs to get routed to just the web mobile servers, or just the web servers. Now you got to figure out which piece of software is responsible for figuring out what message gets where. How do I route it appropriately, and who decides how do they get broadcast to everybody, or do they get routed from one server to another one in particular? That kind of logic is really hard to manage and makes these kinds of architectures even harder to build. So that brings us to RethinkDB. Now that I've sort of said how hard is it to build these kinds of real-time apps, I'm going to just dive for a couple seconds into what RethinkDB is. I mentioned it's an open source database. It's really great for building real-time web apps. So if this kind of experience, Google Docs, Slack, these are the kinds of things that RethinkDB is really great for building. The second thing is it's a NoSQL database. So NoSQL is a funny term. It's kind of like horseless carriage. It's the absence of a technology. It can mean anything from graph database to key value store to document store to anything, but anything that's just not SQL. But in this case, it works with schemaless JSON documents. So you have JSON, you consume JSON from an API, you push JSON to an API. That's what we work with. We have a document model. And that's because we really targeted building these kinds of web and mobile apps or anything that works with dealing with JSON data. And the third thing, we really built it to be a distributed database that's really easy to scale. So it gives you lots of tools to be able to add nodes quickly, to be able to shard and replicate with a couple simple clicks. And the idea is that you should be able to build your real-time web app and then scale it really easily as much as demand grows. So I mentioned that it's built for real-time apps. And what I mean by that, let's talk about what that means specifically. I mentioned that normally you have to poll the database. You have to constantly ask the questions repeatedly. What RethinkDB does instead is it lets you subscribe to change notifications on database queries. So let's just break that down. This is an example query. We have r.table. R means the namespace for RethinkDB, something you would import in Python or require in JavaScript. And we have the table users, and we say .changes. And once that happens, we open a change feed on the table. And we're subscribed to notifications. That is, when something is added, modified, or removed from this table, we're going to get sent a little update, just a little ping, that says, hey, we have something new in this table. And what that means is that it means no more polling, because polling sucks. Instead, the database pushes changes to your app with a live stream of updates. It inverts the traditional database access model from poll the database to find out what's new to tell the database what I care about and then get pushed updates instead. So what's exciting about Changefeeds, what's exciting about this ability to open a feed and subscribe to them, is that it lets you build scalable real-time apps. And to tell you exactly what that means, in this same diagram we talked about earlier, you'll notice that you have these app servers living on top, and there's really only one thing they're ever talking to. There's no queues, there's no other complicated pieces of machinery. There's just the RethinkDB cluster. Each server subscribes separately to a RethinkDB change feed. It opens a connection. A change feed is as cheap as a connection. And then these servers have to know nothing about each other, so they're completely stateless. And that means they can scale easily. Each app is stateless. Each app server is stateless. And it just opens a new change feed separately. And whenever updates become available, RethinkDB will push them to each app server separately. And just so you understand, how do I actually use this in my architecture? I'm mentioning these app servers. On top of each of these, you would have things like Socket.io or Fay or any of this other sort of real-time technologies communicating with the React or Angular front end. This is all in the back-end architecture, but it fits neatly into and really beautifully with architectures where you're building things using React or Angular, any of these sort of like single-page application frameworks. By the way, if anyone has any questions, you can stop me, but I'll give you an opportunity to be able to, we're gonna build something together that's gonna let you ask me questions about the talk. So if you have any, just feel free to stop me at any point in time. So here's what Changefeeds let you build. So I mentioned real-time apps, I keep saying real-time apps. So let's actually talk about a couple examples so you can get a sense for what I'm talking about. For one thing, there's collaborative web and mobile apps. These are the text editors, the Facebook, Twitter, things where people are collaborating or working on things together. There's multiplayer games. Games are a great use case where basically real-time apps become these kind of architectures become very serious concerns. You have things like lots of player events happening in parallel. We have to figure out what is the state in the game world when player actions are occurring, or you have scoreboards that have to be updated in real time. Streaming analytics is another example. If you have an email campaign and you want to be able to find out how are people opening my emails in real time, or I want to figure out I've launched a new ad campaign and how is it actually doing, being able to build streaming analytics rather than collecting and sort of analyzing that data later, it's a great example where you really need to be able to react in real time and understand what's happening in real time. Another example are real-time marketplaces, ad exchanges, think about real-time bidding, anything that involves reacting to data in real time. And this one is actually my favorite, which is connected devices. Because we often build things that are like, we're building something for photo sharing or things that sort of live in the cloud. But like when you have like hundreds of devices that are deployed in an agriculture, like in a field, and they're all collecting data like sensors like water and like what the weather is like and figuring out exactly what the ideal time to plant crops is. You can have all these devices pushing data into the cluster, knowing nothing about each other, and then having some sort of app like a farmer sitting in a field with an iPad saying, oh, it's now I hit a certain threshold, now is the time to go deploy the tractor to plant the fields. Or you can have things like just smartwatches, like you think Fitbit, and you have like data that's coming from in real time that's analyzing on yourself and sharing it with your friends in real time. So this to me is really exciting because it brings like that sort of real visceral experience into the real world. But these are the kinds of things that Changefeeds let you build. So before we talk about we're going to dive in a little bit how this actually works. But before we do that, we have to take one short detour, which is we need to understand how you actually interact with the database. Because it's not quite clear yet when I said database queries, what it means to actually query the database. So we're going to take, there's one query we have here. We're going to count, we call our query language ReQL. And the way it works is that basically you start with your namespace, like R for RethinkDB, and then data flows from left to right. There's chaining, if you're familiar with like jQuery or something like that. You start with your table, you keep moving with the stream, and you do manipulations upon the data as it's flowing from left to right. And if we take this example, we have r.tableusers.pluck_last_name.distinct.count. So to break it down, first, we access the database table. We say r.tableusers. That means that we call it in our system tables rather than collections in Mongo. Similar in SQL, it's called tables. It's just a collection of data. So we say r.tableusers to get the users table. Then we isolate the one document property. We're going to say we just care about getting the last name field from each of these JSON documents with pluck. Pluck will say get that one property out. And then we say .distinct to consolidate all these duplicate values. Say only give me the distinct set of last names. And then we say .count. And now we're actually counting the number of items. And so this basically, you can see, if you ever use tools like underscore or other systems where, other JavaScript libraries or data libraries where you're just sort of working with data and data flowing left to right, it will feel very natural and very easy to use. So here's the magical part about ReQL, though. So ReQL, rather than like in SQL where you send over a string over to the database, or in Mongo where you would send a JSON structure that represents the transformation you want to make to your data, they have to figure out some operators. Instead, ReQL embeds natively into your programming language. So the example I just showed you is JavaScript. But the way it works is that we have drivers for native support for JavaScript, Python, and Ruby. But the community's built something like 17 plus other driver languages, everything from languages as wonderful and esoteric as like Go and Haskell and Erlang and everything out there, Elixir. There's your favorite language is very likely a ReQL driver for it. In fact, I think someone just released a Delphi driver, which I haven't seen Delphi be used in a long time, but it's really fantastic that they cared enough to actually build it for that environment. And what happens is that it looks and feels like native code. So you use your native debugging tools, you use your native data structures, and when you write your query, at the end you just say .run. And what happens is that basically .run will take all the whole query you wrote before, compile it down to take the abstract syntax tree, compile it to an expression, push it out to the cluster, and it gets executed in a distributed fashion. And so when you're saying .map, it may feel like you're writing it in JavaScript, but it's actually saying .map on the cluster in a distributed, efficient fashion. So you can feel, it feels very comfortable, but you always can feel safe knowing that the queries that you're writing are going to be efficient, distributed, and fast. As I mentioned, chaining, distributed on the server, and there are lots of languages that have support for. I'm not going to go into much more of ReQL right now, although we'll play with a few examples in a moment. If you have questions about it, you can come ask me later. OK, so what you can do with ReQL, just briefly, it's a pretty rich database outside of the real-time stuff. There's geospatial, binary features. You could do things like branching and logic. It's actually a whole programming language that masquerades as a query language. But if you want to find out more, the docs have a lot of details, and the API guide is pretty rich. And there's a lot of things you could do with ReQL. So this is the magical part. So I mentioned Changefeeds, and before the example that I showed you was, we have like a table, and let's just find out the documents that get added, modified, or removed. And honestly, that's interesting, but not that interesting. What we realized was that in the system, the way we had built it, we actually, because we had built it to be so parallelized and distributed, we're like, we can do this on any query. And what that means is that we can take this query. Let's say we have a social network. And we want to find out when are the users whose profiles are getting really popular. We want to know when that happens. So we have this query to get notified when a user profile gets over 30 likes. And so we have r.tableUserProfiles.filter. And you'll notice that filter is taking an expression here, because filter the terms can accept functions or expressions. ReQL can do a lot of sort of embedded, interesting things. And we're saying take every row, take every document, and look up the likes property. And when it's greater than 30, then that's like tell me which documents have more than 30 likes. And then we say .changes. And that means only notify me when something that fits that condition actually gets modified, added, or removed. And so clients can basically subscribe to a real-time stream of updates on queries like this, or any other query that can essentially be compiled down to MapReduce, which is most queries. Okay, so let's actually play with an example. So people have laptops, I assume, and things out. So what I'm going to do is I've built a little like real-time app, and I'm going to pull it out right here. And if you go to questions.rethinkdb.com, I'm going to type a question here about RethinkDB, like, who is Jorge? Jorge is sitting right over there. And why is he so cool? There we go. All right, so I have questions coming in. Now, there are little upvote buttons, so you guys can go ahead and click upvote on whatever questions you want to see answered. And feel free to ask questions about RethinkDB, about myself, like anything that seems sensible. I'm going to ask just a few more questions here, like what's Mike's favorite flavor of ice cream? Okay. So I'm going to open a second window here. And you can see that these two things know nothing about each other, and yet they're reacting in real time. I'm just going to upvote a few questions. Feel free to upvote questions so we can see them sort of bounce around. And what's happening here is that basically and I'm going to open the UI for RethinkDB, the admin UI, in just a second. You'll see that you guys are doing it on whatever laptops you have, and these questions are responding and reacting in real time. So if we open up, I'm going to open up the dashboard. Now, RethinkDB comes with a web UI. It's pretty full-featured in that it lets you do things like see writes that are happening in the cluster. Let's see if I'm going to just add like a question like, what was the weather today? You'll notice that we have like a write that happens in the database. So you can see like it's showing you the performance of the cluster in real time. And you could do things like look at how many documents a table has, and can shard and replicate it. You could do operations on it. But the most interesting part, which we're going to stick in this part for the most part, is the Data Explorer. Now, Data Explorer basically lets you write queries in an interactive manner from within the web UI. And I have this query right here, which is saying, I'm going to bump it up. Can everyone read that? Let's see if we can make it a little bigger here. Is that good? OK. So we have r.db, that's the database, and then .table questions. And if I just hit enter, then you'll notice that there are a few questions. In fact, there's some great questions here. And the thing is, let's say I wanted to find out, I want to open a change feed. I'm going to just add .changes. OK, now we have a change feed. You'll say it says listening for events. And I'm going to upvote a question on the left here. And you'll notice that something pops on the right. Now let's examine the output for just 1 second because it's interesting. You'll notice it says new val and old val. Old val is what was in the database prior to this. New val is the new value. And you'll notice that basically the difference is that the points for 7 in one and 8 in the other. That we have more points because I upvoted something. If old val was null, that means that it didn't exist in the database previously. If new val is null, it means we deleted it. So using this, basically, all I have is a socket.io app sitting with I'm using just a front-end framework at the front to basically just open a change feed and then feed a stream of updates and just update myself whenever I get any kind of changes. Just rebuild that part of the data and build that part of the UI. And what we can do is we can say, for example, let's say we'll take this question. Let's just get this question right here. I'm going to take this ID. And by the way, if you have questions about RethinkDB, go ahead and pop them into the app because I'll answer them later. All right, so this question. Ha, nice try, somebody. So we can see the question was r.tablequestions.drop because somebody read Bobby Table's comic and decided to try a little RethinkDB injection. The thing is, RethinkDB doesn't do any string parsing of any kind. So trying to do this, it's just a string. So you're not going to be able to actually execute queries in any way. But I don't like this question because you try to hack the database. So what we're going to do is we're just going to say delete, and we can see that it's at the top here. It's the most upvoted one. And you'll notice that when I say delete, that is now removed. So you can see that wherever the database is manipulated, RethinkDB has the source of truth. It's the single state source that has a consistent state. So as long as I modify that, everything will react and respond in real time. In fact, I just want to show you one more app that I have that's sort of running separately. This is a completely separate app. It's a dashboard for this questions app. And what it has is basically the list of most popular questions that we have. It's a bar graph. And you'll notice that if you guys could just upvote a few more here and there, you'll notice that the graph is reacting in real time to what's happening here. These know nothing about each other. They're not communicating in any way except for RethinkDB. RethinkDB is the only part of the architecture that's connecting them. And this is what I mean by stateless apps. We can add 1,000 more of these, and it'd just be 1,000 change feeds, and it wouldn't complicate the architecture in any way. So let's go back. Why can't I downvote this question? That would be because I didn't bother to implement it. And also, forgive me for bad CSS, by the way. I kind of threw this together really quickly. So some of the questions are a little cut off visually, but that would be because I didn't do a great job. So outside of that, let's see. So let's try something else. Now, I mentioned like writing a query. So let's say we only wanted to see what happens to the top 3 questions. So for the top 3 questions, I'm going to say, first of all, what are the top 3 questions? I'll order by. And I'm going to say, so I've pre-created an index on the points attribute, because our documents have a points attribute. And this index, basically, I say order by points. Let's see here. Opening bracket. Little typo. Right, sorry, I'm trying to do an order by on a get. That's not appropriate. There we go. All right, so these are the top questions. They're ordered by, you'll notice that it's going in ascending order, like 2, 6, 7, 12, 12, 36, 48. So we want to do the opposite, right? So we're just going to say r.desc. Here we go. OK, so r.desc, basically, this is ReQL in action. R.desc says the descending order. And you'll notice that I just wrap it around points, and I'm able to invert the order that that's ordering in. So this is just ordering the set of questions by the top questions. I only really care about the top 3, so I'm going to say .limit3. And you'll notice that now we have our top 3 questions. Now, I'm going to say after this, .changes. And this basically says, tell me all the changes happening on the top 3 documents. Now, let's see, if we're just going to upvote, let's say this one, you'll notice that it's responding to the top 3, but when I upvote, let's say, like, what is your favorite color, it doesn't actually enter the change feed. This is because I've limited the scope of the change feed to the query that I've written. So this basically is this being a real-time app, we can just keep writing queries that we care about, and then open change feeds on the things that we actually care. So if we wanted to build like a top 3 dashboard, we would just have a change feed on order by limit changes. Does that make sense? Does anyone have any questions? We're going to go into the actual questions app in a second, but any questions for me right now? OK, cool. So let's actually take a look at these. Let's answer a few questions. Is it better? Let me see. I'm actually going to do it in here because my CSS is terrible. There we go. All right. So we got, OK, so how's my Memorial Day weekend? Fantastic. My favorite font is definitely not Comic Sans. So whoever wrote that knows me a little too well. What's my favorite part of RethinkDB? That's a good question. So my favorite part is probably either the change feeds, or there's another feature I really like called r.htp. And we kind of built this because we weren't sure how people would use it. But if you have like an API that exists on the internet, you can just access that API directly from within RethinkDB from the servers by saying r.http and then the route that has the JSON feed. So for example, if you wanted to pull down all the GitHub stars for a project, you go to GitHub's API and you just use r.http to pull the data directly into RethinkDB without having to write the usual 20 lines or so of code where you fetch all the data and then you insert it into the database piece by piece. So it makes it really easy to get up and running and sort of use RethinkDB for data exploration. And so I use it often to sort of just say, grab a bunch of JSON and just mess with it and figure out some answers. Those are probably my 2 favorite parts of RethinkDB, but there's a lot of things in there. Who is Jorge? Why is so cool? He's Jorge, and he's cool because he just is. Let's see. Is it better to monitor changes per event or per user? Let's see, per event or per user. Whoever asked that question, could you clarify the question for me?
So yeah, if you're monitoring a whole bunch of feeds and if there's a whole bunch of different boards, is it better to have a change feed listening for the things relevant to that user, or listen to the board and then push it out to whatever users are paying attention to?
Yeah, so if I understand, so the word user, I have to define it more clearly. If you're talking about you have like an app server and it has like a limited set of data that it cares about for one user, it would open a change feed that says, well, just filter out everything except for the bits of data that I care about. And you could choose. It really just matters about how much activity you want within the cluster, like network traffic. So if you really want, like, let's say you have an app server that only cares about a certain set of users, you just for that app filter the set of users to just care about that set of data. Does that answer your question, or is there a different? Am I not understanding it correctly?
I guess what I'm trying to ask is it okay to have is it better to have lots of very targeted change feeds or fewer broader ones? Like, what's kind of the trade-off between those two?
Yeah, it depends on your use case. So I mean, as I said, a change feed is as cheap as a connection. So you could open a ton of change feeds, and it's going to scale as easily as connections do. It depends upon how much data you expect. Like, if you expect it, like, you only care about a small set for a particular like app server, then it's better to focus your change feeds. If you don't, and you think it's generally, then your code might be simpler if you just had, one generic change feed for the set of data you care about. Does that make sense? You can scope it as widely or as narrow as you like. It just depends upon the use case for your app, how much of the data within your cluster you actually care about accessing for a particular app server.
Okay.
Seems reasonable?
Sure.
Okay. So if you want to check out the code yourself, you can go to, I'll post this on Twitter later, but there's a GitHub repo where I've posted some of this code. It sort of will help you get started and is a basic intro to how to do these kinds of apps. So just to recap briefly, I mentioned this kind of architecture before. We have our question server and the dashboard. These are sort of two separate apps. They know nothing about each other, and yet they're communicating with each other by going through the RethinkDB cluster. It is that one single state of truth. Now, as I said, changes are pushed to each stateless app server. And this really is what has to happen to be able to build these kinds of architectures at scale. We have to resolve the problems that I mentioned about earlier. So as I said, polling for data, it's slow, it's cumbersome, it's hard to maintain. The push access model, meaning where the database as the source of truth is pushing through the entire architecture, it simplifies real-time architectures dramatically. One source of truth, that being the RethinkDB cluster, makes it easy to manage state. And RethinkDB is the first database that's designed for the real-time web that has this inverted database access model that pushes data from bottom to top. So if you want to learn more about RethinkDB, and I would urge you to, you can check out the website. You can read our docs at rethinkdb.com/docs. And if you want to find out about new blog posts and new releases and all sort of fun stuff happening on our team, follow us on Twitter at RethinkDB. I think some other people are going to go through some deeper concepts and aspects, how they're using RethinkDB and how it's built at a lower level. So that's all I have for you guys today. And if you have any questions, just come find me afterwards. Thanks a lot.